from electrical branch 20D. My roll number is 20D22. Today I will be talking about smart grid. A smart grid is an electrical grid which includes a variety of operation and energy measures, including advanced metering infrastructure, of which smart meters are generic name for any utility site. Devices, even if it is more capable, example like a fiber optic cable, router, smart distribution boards and circuit breaker integrated with home control and demand responses. Load control switches and smart appliances often financed by efficiency gains on municipal programs such as PACE financing. Renewable energy resources, including capacity to charge parked electric vehicles, batteries or larger arrays of batteries recycled from these or other energy storage. Energy efficient resources and sufficient utility grade fiber broadband to connect and monitor the above with wireless as backup. Now I will be talking about historical development of electrical grid. The first alternating current power grid system was installed in 1886 in Great Barrington, Massachusetts. At that time, the grid was a centralized unidirectional system of electric power transmission, electric distribution and demand-driven control. In the 20th century, the local grids grew over time and were eventually interconnected for economic and reliability reasons. By the 1960s, the electrical grids of developed countries had become very large, mature and highly interconnected with thousands of central generation power stations, delivering power to major load centers via high capacity power lines, which were then branched and divided to provide power to smaller industrial and domestic users over the entire supply area. The topology of the 1960s grid was a result of the strong economies due to efficiency boosting, the features that can be cost effective only when the stations become very large. And the next topic is early technological innovations of electrical grid. Smart grid technologies emerged from earlier attempts at using electronic control, metering and monitoring in the 1980s. Automatic meter reading was used for monitoring loads from a large customers and evolved into the advanced metering infrastructure of the 1990s, whose meter could store how electricity was used at different times of the day. Smart meters and continuous communication so that monitoring can be done in real time and can be used as a gateway to demand response aware devices and smart sockets in the home. Early form of such demand side management technologies were dynamic demand aware devices that passively sense the load on the grid by monitoring changes in the power supply frequency. Devices such as industrial and domestic air conditioners, refrigerators and heaters adjusted their duty cycle to avoid activation during the time the grid was suffering at its peak condition. Beginning in 2000, Italy's Telegestor project was the first to network large numbers such as 27 millions of homes using smart meters connected via low bandwidth power line. Communication reliability. The smart grid makes use of technology such as state estimation that improves fault detection and allows self-healing of the network without intervention of the technicians. This will ensure more reliable supply of electricity and reduce vulnerability to natural disasters or attacks. Although multiple routes are touted as a feature of the smart grid, the old grid also featured multiple routes. The initial power line in the grid were built using a radial model. Later, connectivity was guaranteed via multiple routes referred to as network structures. However, this created a new problem. If the current flow of the related effects across the network exceeded the limit of any particular network element, it could fail, and the current would be shunted to other network elements, which eventually may also fail, causing a domino effect. See power outage. And a technique to prevent this is a load shedding by rolling blackout or voltage reduction. Now I will be talking about features of the smart grid. The smart grid represents the full suite of current and proposed responses to the challenges of electrical supply. Because of this diverse range of factors, there are numerous competing taxonomies and no agreement on a universal definition Now I'll be talking about the efficiency of the electrical grid or smart grid. Numerous contributions to overall improvement of the efficiency of energy infrastructure are anticipated from the deployment of smart grid technology, in particular including demand side management. For example, turning off air conditions during the short-term spikes in electricity prices, reducing the voltage when possible on distribution. Lines archived in 2013-06-27 and the Wayback Machine through voltage VAR optimization, also called as VVO, eliminating truck rolls for meter reading and reducing truck rolls by improved outage management using data from advanced metering infrastructure systems. The overall effect is less redundancy in transmission and distribution lines and greater utilization of generators, leading to lower power price.